Hello guys, this is CodeNCode and this is the first lecture of this dynamic programming series part 2. I decided to break the dynamic programming course into two parts so that I can run both the DP course for beginners and for advanced students in parallel, so that the student who want to learn advanced concept like DGDP don't have to wait, because otherwise I would have taken much time to explain the beginners course of DP, because I don't want to rush beginners, and it is not a good idea to rush someone because you need to give them time, especially for concepts like DP or combinatorics. So I don't wanted to rush beginners, so I thought to I decided to break the course into two parts, so that now I can run both DP part 1 and part 2 in parallel, so no one have to wait. So this is first lecture. In this lecture we are going to solve this problem, Caesar's legion, which is taken from codeforces and it is rated 1800. The problem is not only about solving the lecture is not only about solving this problem, but in this lecture I'll be taking you through the way we would be solving most of the DP problems. So it would be an introduction to the way we would approach a DP problem. So let's start. So the problem is, there is a guy Caesar and he has an army of n1 plus n2 persons or army men. So n1 of those are footmen and n2 of those are horsemen. So what you have to do, what he wants to do, he wants to arrange them in a line. So the line would contain n1 plus n2 people or army men in total. So but he thinks that the arrangement is not beautiful if more than k1 footmen are consecutive or more than k2 horsemen are standing consecutively. So if there are more than k1 consecutive footmen or there are more than k2 consecutive horsemen in the arrangement, then this is not a beautiful arrangement. So we have to we are given n1, n2, k1 and k2. We have to find the total number of beautiful arrangements, and since we are arranging n1 plus n2 completely, so of course the arrangement would contain n1 plus n2 total warriors. And yeah, this is all, I guess. And one more thing, I guess we have to print it modulo transfer 9 plus 7. We would look at that later. So for now we are given n1, n2, k1 and k2. n1 the number of footmen, n2 the number of horsemen, and k1 the upper limit on the consecutive footmen, and k2 the upper limit on consecutive horsemen, and we have to find the total number of beautiful arrangement. So n1 is number of footmen, n2 is number of horsemen, and k1 is number of consecutive footmen that we can place, and k1 is number of consecutive footmen we can place, and k2 is number of consecutive horsemen we can place. I'll be representing footmen as x and horsemen as y. So the first test case says that we have to place 2x and 1y such that no more than one consecutive x appear and no more than 10 consecutive y appear. Now the total length of string is going to be 3, n1 plus n2. So we have to find the total number of length 3 strings such that no 2 consecutive x are there, no more than 1 consecutive x are there, no more than 10 consecutive y's are there, and number of x are 2, number of y are 1. So if we take these two only, first if we apply only first two restrictions which are n1 and n2, number of x should be 2 and number of y should be 1. So these are the only possible configuration using 3 characters, where 2 are x and 1 is y. So out of these 3, only the middle one is valid, while the other 2 are invalid because there are 2 consecutive y's in there, while we are only allowed to have 1 consecutive y, at most 1 consecutive y. So first and third are invalid conditions, the only valid string is second, so the answer is 1. Now the second test case says find the total 5 length string such that there are 2x and 3y. So 2x and 3y such that there are no more than one consecutive x in there and no more than 2 consecutive y's are there. So you see, in all of these 5 examples there are no more than one consecutive x and no more than 2 consecutive y's. So these are the only 5 valid strings, so the answer is 5. So to approach the DP problem, first you have to think about the restrictions that we have. For this problem we have these 4 restrictions. We have to make a 5 length string using characters as x and y, but it's not like you can fill each place by x and y. No, there are these 4 restrictions. First, and number of x in the string of length n1 plus n2, there should be n1 x and n2 y. It's not like n1 was 1 and n2 was 5. That is, you have to make 6 length string and all 6 characters you filled with y. That would be invalid. So we have these 2 restrictions. N1 character should be x and n2 character should be y, and these are the rest 2 restrictions, that there should be no more than k1 consecutive x and there should be no more than k2 consecutive y's. So these are 4 restrictions that we have. So we'll keep in mind while solving this problem, we'll keep these 4 restrictions in our mind. So to find the solution, first we are going to write a recursive algorithm, and to write down a recursive function, first when we would write a recursive function we would think of no restriction at all. So we are going to create a function getAnswer which takes n, indicating we have to find the total number of n length string such that each place can be filled with x and y. So let's assume getAnswer that takes int n, which indicates the total number of army men. B, the function to return the total number of beautiful arrangements with f footmen and h horsemen, and no more than k1 consecutive footmen and no more than k2 consecutive horsemen. So this function appears to have all the restriction with it, but it is actually having none restrictions. So first we will define this function without thinking about these restrictions, and then one by one we will be we will be applying those restrictions, and finally the function would be able to give us the result of each test case. So to get the answer, all we have to do is call the function getAnswer n1 plus n2. But remember, this won't be the actual answer because we are not applying any restriction to it, but we would start from the point where we have no restrictions. So let's jump into the editor. You guys should be able to see this. I think this font size is, come on, good. Now, so I've taken 2 variables, limit f and limit h, instead of k1 k2, so it indicates k1 and k2. For now just remove this, we don't need it. Remove this, we don't need it. So according start from here, I have t, n1, n2 and k1 k2, right? So we take input t test cases, and in each test case we would be given n1, n2 and limit on footman, that is k1, and limit on horsemen, which is k2. So answer is equals to get answer n1 plus n2. Now let's create the function getAnswer. So if n is equals to 0, that is there are no characters to fill, you return n1, which would indicate actually you have reached to an end of a valid string. That is why we are returning 1. Suppose n was 3, so you have reached the 4th character. That is, you have filled all 3 characters and now you are at the end, and from that point we would return 1 because we are at the valid end. And you should know this because of course, as I've already explained, this is part 2 of dynamic programming, so you should be able to understand recursion. Now I can fill this character. What getAnswer tells you is the total number of n length string where each character can be filled with f or h, right? So this character, the ith character, we are the nth character we can fill with either f or h, right? So let's fill current character with f. So int x is equals to, if you fill the current character with f, then you are left with n minus 1 more characters to fill. So we'll call getAnswer n minus 1 because the current, that is the nth character you have filled with f, right? Or let's fill the nth character with h. Fill the nth character with h, so it would be y. Total number of ways would be y. getAnswer n minus 1. And then finally, since this is the total number of ways to fill the to create a n length string where the nth character is x, and this is the total number of ways to make n length string where the nth character is y. So since our nth character can be x or y, so the total number of ways would be x plus y. You should know this because for dynamic programming course part 2, that is this course, recursion is actually prerequisite, so you are required to know that the recursions. So you can see that this you should know what we do, how we define the recursive function. We define first the base case, then we define the transition, and finally we return the result. So now you can see that x and y both are actually getAnswer n minus 1. So we could have returned 2 times x. Yeah, that is perfectly fine, but I'm writing down this way so that we know that okay, this place we have filled with f and this place we have filled with h. Or instead of f and h, let me write x. No, it would make more sense if I write down f and h. Now if you print the answer, you just think what you'll get, what the answer you are bound to get if we run this code. Okay, so suppose we have 5 test cases. Suppose the first input is 1, 2, and it doesn't matter what, enter x or y. So the answer is 8. Now see why it is 8. See, our function getAnswer currently have knowledge only of n, so it only knows how so it can only tell you the total n length strings such that each place can be filled with x and y. So we are asking it to tell us the total number of n1 plus n2, or total number of strings of length n1 plus n2, which is 3. So total strings of length 3 where each place can be filled with x or y is actually 2 raised to power 3. That is why you are getting 8. So take an example of 3 and 7. It doesn't matter what you fill here. Answer is coming out to be 1024, which is 2 raised to power 10, which is n1 plus n2. So our function is working fine because we are able to generate all n length string. But the problem is this is without any restriction. So let's impose, or let's apply restriction 1 and 2. So apply the restriction 1 and 2 says that okay, there should be no more than, or there should be exactly n1 amount of f or x, that is footman, and n2 amount of y. So to make decision before filling the ith place, what we are doing here, we are filling the current place with f without having the knowledge whether we have sufficient amount of f or not. So goes for h. We are filling current place as h without thinking whether we have sufficient h or not. So what we will do, we will also pass 2 more parameters so that it can this get answer function can make decisions whether I have left with some f or h or not. So from main function now we would pass n1 and n2, because n1 is the total amount of f we can use and n2 is the total amount of h we can use. So it is important that our get answer function have knowledge of f and h to make decision whether the current place can be filled with f and h or not. So that is why we would have two more parameters, f and h, and from the main function we would pass f, which is n1, and h, which is n2. Right now we are trying to apply first two first two restrictions. So int x is equals to 0, initialize int with 0. Now to fill with f, the number of f, the remaining f, this indicates the remaining f should be greater than 0, because there should be at least one f to fill the current position with f. So x is equals to get answer n-1, because the current place is filled, so we are left with n-1 more characters to be filled. Now since the current character is filled with f, so f would reduce by 1, but h would remain as it is, so it won't change. Now so goes for y. Fill the current we can fill the current character with h if number of horsemen are at least 1. If that's the case, then get answer n-1, because we have made decision for nth character, we are left with only n-1 characters. F won't change because we are filling the current character with h, so h would reduce by 1. This is all. Now let's first close this. Let's run it. Okay, so 5 test cases, 2, 3, 5, 4, last doesn't matter. So it comes out to be 10. If we hadn't applied these two restrictions, the answer would have been 2 raised to power 2 raised to the power 5, which is actually 32, but this time it is 10. So if you find the total 5 length string where each place can be filled with x and y, and there are no more than 2x and no more than 3 y's, so the answer would be 5c2 or 5c3, where c is commutative, what we call it, binomial coefficient. So if you see 5c2 is actually 10 or 5c3 is 10, that is why we are getting this time 10, which indicates total 5 length string using 2x and 3y's. So now let's just confirm it using this 195. So the result would be 10c9 or 10c1, which is 10 actually. So we are getting the right result. Now our result is our function is able to generate all length n string where x and y are n1 and n2 respectively. So we now have successfully applied these two restrictions, that is restriction 1 and 2. Now to apply restriction, the last two restriction, the problem is our function must be able to determine that the current place can be filled with f or not. To do that, we have two restrictions. First, that f should be greater than 0, that is we must have at least one f remaining, and the other condition is that this x would the other restriction was that okay, there should not be more than k1 consecutive f, and there should not be more than k2 consecutive y's. So this would indicate these many x you can still place, right? Initially it would be k1, and this indicates these many y you can still h you can still place consecutively. So initially it would be k1 and k2. So what would happen if the current place initially you passed k1 and k2? Okay, so what it tells, okay, you can fill these many x many consecutive f and these many consecutive y's. So take an example of this. So from suppose k1 and k2 both are 3. So we passed x and y as 3 and 3. So now we are at this place. Now since we have placed two y's consecutively, so y would become 1. So now what would happen? Think about it. Suppose we are on the first position, and we just made a function called getAnswer with these all these parameters, and now we are filling the first character as x. If you are filling the current position as x, now the number of allowed consecutive x would reduce by 1, because you have placed suppose you have not filled y and y, you have only filled x. So since the first place is filled by x, and limit is 3, so now you are allowed to fill 2 more x, right? So initially it would be 3, and if you fill the current position with x, then this would reduce by 1. Now since the first place you filled with x, and suppose you are on this position, now the third character you filled with y, so what would happen? Y would become 1, because you have placed last two character as y. So now this would become 1, because k2 was 3, k1 and k2 was 3. You have filled already two consecutive position with y. So the third, so y would become 1, this y would become 1, indicating you can place one more y character. Now since you fill the third character with y, as soon as you fill the third character with y, this becomes again k1. If you fill the ith character with y, now you can fill complete k1 characters with x, right? Because previous character is not y, so it won't include, or it won't change the fact that you can place k1 x's. So if you filling current position as y, then x, this would become k1 completely, and this would become y minus 1, because you fill the current place, and now you are this was the allowed number of y you can place. Since you place one y out of those, so y would be reduced by 1. So this is what we are going to do. Now initially, how many footmen we can place consecutively? Initially I can fill k1, which is actually limit on footmen. And how many consecutive y's or horsemen you can place? That is limit on h initially. So the first condition that we check is that the first condition we have to check is whether footmen are available or not, that is their count is greater than 0. And the second condition you would check whether let me fill it, int x and int y. So since there are no k1, let's use k1 and k2. Since and k1 is total number of allowed f you can still fill, so k1 should be greater than 0, indicating that you have not consumed all consecutive footmens. So if you fill like initially k1 or limit on f was 3, and you have already filled 2 f consecutively, then k would become 1. Now you have to check whether you are allowed to fill at least one f or not, so it have to be greater than 0. This indicates basically number of footmen you can still place consecutively. So if you do that, if you fill the current position with footmen, then k1 would reduce, that is allowed number of consecutive footmen would reduce by 1, because you have filled the current place with footmen. And k2 would again become completely, because current place you have filled with f, now you are allowed to fill completely limit h, that is k2 characters of y. So that is why k2 would become limit of h completely. Now if you fill the current position to fill with f, that is horsemen, you have to check two conditions. First, there should be at least one horseman, and there should be at least one allowed horseman to be filled with greater than 0. Sorry. If you do that, if you fill the current position with f, now k1 would become limit on f, because the current position is filled with y, so you are now allowed to fill complete. You can completely fill k1 amount of f, and that would still be valid. And for k2 would reduce by 1, because from allowed k2 elements we have used one element, and this is all. This should give us the correct result. Before going into it, this is the problem that we are solving. Seriously, listen, this was D problem from beta round 89, and this is rated 1800 dp. Now these are the test cases we would be testing on. So there are 3 test cases. For 2 1 1 1 0, the answer is 1. 2 3 1 2, the answer is 5. As you can see, the input is this, output is this, and the last input is 2 4 1 1, and the answer is coming out to be 0, which indicates that we have successfully implemented all of the restriction, and the answers coming out are exactly the answer that we want. So now we have successfully built this getAnswer function. So how we did that? We first we built the getAnswer function without any restriction. We build it, and then one by one we implemented each restriction. Now once you have created a function, a recursive function, to solve a DP problem, the second thing you do is you create a DP. This is long int because it can go out. There may be overflow, that is why we have to print it modulo 10 to the power 8, right? So to take care of integer overflow, I'm taking long int. Now to convert, since you are familiar with basic DP, you know how to convert the recursive code into DP1. All you do is create a function. You create a memoization table, let's call it DP, and it would have 5 dimensions, 5D, because there are 5 state variables in here, n, f, h, k1, k2. That is why it would be a 5D DP. But think carefully. Think about this. Do you even need n? Just think for a second. Actually, you do not need n, because f plus h is actually equal to n in each time, because initially n is what? n1 plus n2. This is n1 plus n2. If you fill current position with f, n would reduce by 1. That is why it is reducing by 1. So will f. Or if you fill the current position with h, n would reduce by 1, and so will h. So each time n can be calculated as f plus h, so you don't have to keep track of n actually. So it would reduce our DP to be from 5D to 4D. All you gotta check is f plus h is 0 or not. That is, you have consumed all x and all y or not. If you have, then you are at the end of the string. That is why you would return 1. So you don't have to pass n. It would reduce the space. You might have heard of state space reduction. This is what it is. So what you do, you remove any state which is redundant. N was redundant because you can calculate n from f and h, so you don't need n here. So now it would make our DP 4D DP. First one would be for f and h can be as large as 100, I guess. Yes, n1 and 2 can be 100, and k1 k2 can be 10. So 100, for 100 I would be using 101, 11 and 11. Now this is our DP. To reduce the time limit, what we do, we check whether we have been to this state or not. To do that, we check in our DP of f, h, k1, k2. If it is not equal to -1, because initially we would fill the let's just initially, before making call to get answer, let's fill the DP array. You can use memset, MEMSET, I guess. This is a function to fill the values, but I do it this way. So skip this if you think you can fill the DP array with memset. Just go ahead and do this. I do it this way. I is equals to 0, I less than equals to n1, I plus plus, j is equals to 0, j less than equals to n2, because this is n1, this is n2. That is why first two places, first two dimensions are for n1 and 2. That is why I and j are n1 and 2. Lastly, k less than equals to k0 k less than equals to k1, or limit on f k plus plus, and finally L is equals to 0, L less than equals to limit on h, it is L plus plus, finally dp of I, j, k and L is equals to -1. So each place of this dp we have filled with -1, which would indicate that this state has not been visited. So if this state is not equal to -1, which indicates we have been to this state, and then we would finally, instead of making these recursive calls, we would direct return result from here. Otherwise we would calculate the result, and before returning we would save it into the dp array. And since we have to print it modulo 10 to the power 9, 10 to the power 8, that is why it is important to take modulo after calculating the result. So mod, this is, I've already defined it to be 10 to the power 8 because we have to print it modulo 10 to the power 8. So mod is actually 10 to the power 8. So finally you would return the result from here. So let's test and hope that we don't get any error. Yeah, we didn't get any error. So let's test it finally. There are 3 test cases. 2 1 1 1 0, the result is 1. 2 3 1 2, the result is 5. 2 4 1 1, the result is 0. So we are going right till now. So let's submit it and see what we get. Hopefully we get an SE. Oh, will not. We forget to do this thing. There are not t test cases, there is only a single test case each test file. So initialize t to be 1 because we are going to get a TLE or something like that. I forget it. Come on. Yeah, wrong on test case 1. So since there are only, in each test file there is only one test case, so setting t is equals to 1 would do just fine. So let's submit it. Okay, is it running fine? Yeah, AC. So you see, this is how we solve this scissors lesion problem, which was rated 1800. Where is it? Rated 1800. It was a DP problem. So the problem was given. In the problem, we were given 4 different restrictions. Initially, we created the get answer function without having any restriction, and then finally we one by one imposed all the restrictions, and finally the function was able to give us the result for each test case. So this is how we would be approaching most of the DP problem. First we would create the function without any restriction, and then one by one we would be implementing the restrictions, and finally the function would have all restriction, and hence the function would return the result that is intended to give us the intended result. So this was all about this what we call it, lecture. Yes, and in the next lecture we'll be taking on some other important and interesting problems before we get on to DigiDB. So thank you guys for watching, and yeah, till the next video drops, keep coding. Thank you.